Hello, 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 everybody. In this video, I'm going to go over the characteristics of a cube root function given the cube root function on a graph. All right, let's look at this first example. Obviously, the parent function, since it's a cube root function, will be f of x equals the cube root of x. All right, now, before we start answering the rest of the characteristics, let's go ahead and label our endpoints. Now, if you notice in this graph versus the square root function graph, I have an arrow on both ends. So I need to just pay attention to which quadrant the arrow is in. Let's look at this arrow over here on the left side. As you can see, it's in the third quadrant. So that means all of my x values are going to continuously go to negative numbers, and my y value is going to continuously go to negative numbers. So the way I will label this arrow is negative infinity, comma, negative infinity. And I also got that from right here. And then if you look at my arrow on the right side, as you can see, it's in the first quadrant. So the way I'll label that arrow is positive infinity, comma, positive infinity. All right, my domain and my range for cube root functions will always be all real numbers. And that's clearly because on both ends of the graph, the arrow keeps going. So it's going to cover every x value and every y value. My x-intercept, I'm going to look along my x-axis. And as you can see, my x-intercept is right here at negative 3, 0. And sometimes people refer this to finding your zeros. Your y-intercept, I'm going to look on my y-axis. Now, I clicked on it when I was on Desmos. So if you are given a function, make sure you type it in Desmos and click on the dot where it lands on the y-axis. So my y-intercept is going to be 0, 2.26. Now, for my end behavior, that's when I go to my arrows and I write exactly what the x and the y are doing on both sides. So let's look at the left arrow on the graph. As you can see, I wrote down that the order pair was negative infinity, negative infinity. So for my end behavior, I'll say as x approaches negative infinity, f of x, which is the same thing as y, approaches negative infinity. And then for my right side of the end behavior, I will go to the right arrow. And as you can see, this order pair says positive infinity, positive infinity. So I will say as x approaches positive infinity, y approaches positive infinity. And that's it.